Today's problem is reverse a doubly linked list. Difficulty easy, accuracy very high, 70%. You are given the head of a doubly linked list. You have to reverse the doubly linked list and return its head examples. Okay. So we have this list, 3, 4, 5. Links next and previous link of the head node is null, next link of the last node is null. Reverse it. So what you have is 5, 4, 3. Okay. Let's see, number of nodes. At least one. We'll have at least one node. And up to 10 to the 6th, 1 million. Let's see, node data, that's not too important. Complexities, linear, auxiliary space, 1. You could do this recursively, but you wouldn't get O1 auxiliary space, so that's not what we're going to do. Company tags, topic tags, nothing helpful there. All right, well, let's take a look at this. Here's what a node looks like up at the top here. Reverse. What we need to do is just traverse the list and swap the previous and next pointers. So, let me slide this over a little bit. You see everything there? Okay. So we'll use a couple of pointers. A temp pointer. A temp node and a current a temp node and a current node. Let's say it that way. So current node initialized to the head node temp. We're just going to use that to swap pointers. All right, we'll iterate through the list while current is not equal to null. Put the previous pointer into temp, put the next pointer into previous, and put the temp pointer into next, and then advance the current pointer. Current equals current dot prev. Now it looks like we're going backwards, but remember that we swapped the next and previous pointers. So what was the next pointer is now the previous pointer. For example, in this one here, 3, 4, 5. When we start out, the next pointer points to 4, and we swap it, and that becomes the previous pointer, so that we would eventually wind up in a situation like this, where 3, the previous pointer, points to 4. But 3, current.prev, in this case, now points to 4, and that's where we want to go. So we've swapped them. So we do want to go to current.prev, and that will take us to 4. Now, one other thing is, in a way, you could do the same thing here by putting the next pointer into temp, and then previous into next, and temp into previous. But the problem with that is we're going to get to the end of the list. We're going to use temp to help us return the head pointer. Now, we can't do that if we put, so when we get to the end of the list, the 5 node, for example, if we put next into temp, and previous into next, temp into prev, temp now points to null. That really doesn't help us at all. If temp points to the previous pointer of this node, then we're good, because it's going to point to the 4. So when we get down here and we do the return, we can return, and again, temp is pointing to the 4, and so we can return temp.prev, which is now pointing to 5, which is now the head node. We've got an edge case here, and you could, if you wanted to, just handle that at the beginning. It's not much of a difference. Let's see, current not equal null. Let's see, so that's going to be null either way. Yeah, you could handle it at the beginning, but what's going to happen? This is going to handle cases where you only have one node. Temp.prev is going to wind up pointing to null. So we'll just return the head. Otherwise, we'll return temp.prev. Actually, as I'm looking at this now, that looks wrong. I think maybe it should be temp equals null. Temp equals null. You know what? I think it should be temp equals null. Okay. Get ready for a quick failure here. If so, we'll fix it. But all right. Submit. No, that was the right one. Okay. So reverse doubly linked list. Pretty easy. Just traverse the list, switch the prev and next pointers, return the new head. So good. Please like the video, subscribe to the channel. It's free, and I will see you next time.